So we should have two weeks to study impulse and momentum. And this is week 8. We also need to study week 9. In week 9. Monday will be a public holiday. So that means we can't run any lecture. Because of this, I have to deliver the content in week 9 and week 8, both in this week. Okay. So we will study impulse and momentum. And for impulse and momentum, as I mentioned in last week, to some extent, this can be treated as some problems involving velocity and time. But not all the problems. For some problems, impulse and momentum method may be the only method. Okay. So let's start. Let me check. Doesn't work. Okay. Let me restart. Okay. Let me. Yes. Okay. So next slide. I think we should start this topic by recalling what you have particle dynamics. So linear impulse and momentum. How the equation can be. So let's have a look. In particle dynamics, firstly, I think you should be familiar with this equation. The second law of Newton. For this one. For this equation here. So for this equation here, if you express acceleration A using dV dt, and then rearrange move dt to left side, and then you can do integral on both left side, right side, and then for this will be called linear impulse for a particle. Linear impulse measures the effect of a force in a time duration. For example, T1 to T2. But what should be this effect? The effect is to change velocity of a particle. And what you can see on the right side. Okay, on the right side. Okay. And on the right side, this is called momentum. And that's the result of linear impulse. And this equation is for particle. Okay. Now, angular momentum for a particle. How to define this? Look at this diagram. And we assume there is a plane X, O, Y. And here you can see there is a particle, and it has a velocity V. So we know the linear momentum of this particle should be mv. But what about angular momentum of this particle? We select a point. For example, origin point of this reference and we have an axis going through this point O, and you can see this axis must be perpendicular to this plane X, O, Y. Okay, now you can find moment from point O to M, V, M, V. MV is a vector, so it has the direction. It has the direction as the same as the direction of velocity V. Okay, then you use MV times the distance from O to MV. Then you will be able to get the so-called angular momentum. In this one here, only the magnitude. Angular momentum, linear momentum, both vectors. So vectors. If it's a vector, then we should have how to determine this direction. For linear momentum, we know the direction same as the direction of velocity. But for angular momentum, this direction must be determined using right hand. We already know how to use the right hand rule. In this case here, the direction is angular momentum. About axis going through point O could be counterclockwise upward. Okay. So that's angular momentum for a particle. And we studied the principle of impulse and momentum. And this can be about the linear impulse and also can be about angular impulse and momentum. Now, based on the knowledge you studied particle dynamics. Let's move to rigid body dynamics. So, in the first part, we will learn how to define and calculate linear and angular momentum for a rigid body. And then, in this first part, we will study principle of impulse and momentum. Okay. For linear and angular momentum. Let's focus on linear momentum. For a rigid body, calculating linear momentum is like this. And in this one here, means linear momentum. Is the mass of the rigid body. VG is the velocity and the mass of this rigid body. Quite easy. So it's quite easy. VG, you will be able to work out linear momentum. And the linear momentum is its direction exactly as same as the direction of VG. SI unit linear momentum is kilometer per second. So this one should be easy to understand. And this equation looks similar as the equation for calculating linear momentum of a particle. Now, angular momentum. When we talk about the calculation of angular momentum of a rigid body, we have to define an axis. So, for example, here, we assume this rigid body is. Let me use laser point. Okay. We assume this is a rigid body on the maybe a translation, or general plan motion, rotation about a fixed axis. Now, if we randomly select point P for our calculation, you will have these two equations. And this one is the angular momentum of this rigid body about an axis going through point P. This one there. So these two equations,
these two
this one
equations
and this
this
one
one
should give
and this
us
one
the
should
same
give us
result.
the
The
same
difference here
result.
is
The difference
in
here
the
is
first expression.
in the first expression.
It uses the
It
velocity
uses the velocity at the
selected point P.
point
But
P.
in this one here,
But in this one here,
the velocity is the
velocity
velocity at
is the
the
velocity
mass
at the
center
mass
point G.
center point G.
Now, this is the
Now,
general
this is the general expression
of calculating
calculating angular
momentum
momentum of a rigid
and
body.
it looks complex.
And
actually
complex.
we can
And
do
actually we can
simplification.
do simplification.
So how
Okay.
to do this?
So how to do this?
What we can do is
we
move
move
point
point
P
P
to
to
point
point
G.
G. That
If
means
we select
if we
the
select
mass center
the
point
mass center
G
point
of this rigid
G
body
of this
for
rigid
our
body
calculation,
for our
we should
calculation,
be able to
we should be
simplify
able
this
to
equation.
simplify this
How?
equation.
You
How?
can see if you select
You
a
can
point
see if you
G
select a point
for your
G
calculation,
for your calculation,
and then the
and
moment
then
arm
the moment
for
arm
M
for
VGY and M
VGY
VGX,
and M
the moment
VGX,
arm,
the moment
X
arm,
bar
X
and
bar
Y bar,
and
both
Y bar
should be
both
zero.
should
Okay.
be zero.
So
Okay.
finally,
So
in the
finally,
equation, we only
in the
have
equation, we only have the
angular momentum
angular
of a rigid
momentum
body
of a rigid
can
body
be
can
defined
be defined
IG is the MMI of this rigid body
of this rigid body
times omega.
times omega.
Again, omega
Again,
is the vector,
Omega is the
and
vector,
angular
and angular
momentum of this rigid
momentum
body,
of this rigid body
is
Hg
the vector.
is the
The
vector.
SI unit
The SI
now
unit
is
now
kilometer square.
kilometer square per
For
second.
linear
For linear
momentum is kilometer
momentum,
per
kilometer per
For angular momentum,
for
is
angular momentum,
kilometer square.
kilometer square.
So be careful.
So be careful
SI
with
unit.
this SI unit.
Okay. So
Okay.
actually,
Actually,
any point
any point
can be selected
can be
to
selected
calculate
to
the angular
calculate
momentum.
angular
But
momentum.
if you
But
select
if you select
points for your
different
calculation,
points for your
you
calculation,
will get
you will
different,
get different
different magnitude
different
for
magnitude
angular momentum.
angular momentum.
Okay. Okay. So that's the calculation of angular momentum.
Angular momentum.
Now, so far,
Now,
probably
so far,
you will fail
you will fail
the equations of calculating
of calculating
linear and angular
linear
momentum.
and angular momentum.
Looks
Looks
similar
similar
to the equation
to the
you have
equation
studied in
you
last
have
week
studied in last
when we
week
discussed the
when we
topic
discussed
of
the topic
work and energy.
of work and energy.
So in this one here, I have to
see
work and energy. This
work and
method
energy.
or
This method
is
or
actually
this topic
very much
is actually
different
very
from
much
the topic
different from the
or
topic
method
or
of
method
impulse and
of
momentum.
impulse and momentum.
They are very different.
They are very different.
Work and energy,
Work and energy.
they are scalars.
They are scalars.
Impulse and momentum,
Impulse
both
and
of
momentum.
them
Both
are
of them are
vectors.
vectors.
They have magnitudes.
They have magnitudes. They
direction.
have direction.
But the equations
The equations
look similar.
look similar.
So I suggest
So, I suggest
when you study
this topic
impulse and momentum,
impulse and
it
momentum,
could be better
it could be better
you to
for
compare
you to
the
compare
knowledge
the knowledge
we studied on
we
this
studied
topic
on this topic
and on the topic of
and
work
on the
energy.
topic of work
Compare.
energy. Okay, compare.
So this probably
So
can
this probably
be helpful
can be
for
helpful
avoiding
for
any
avoiding
confusion.
any confusion. Okay.
Let's have a look.
Let's have a look.
For translation,
For translation,
how to use this
how to use
equation.
this equation.
For linear momentum,
For linear
always
momentum,
stay.
always
Translation,
for translation,
rotation about a fixed
rotation
axis,
about a fixed
or
axis,
general
or
motion,
general
all the same.
flat motion.
But
All the
for
same.
angular
But
momentum,
for angular momentum, there
are some kind
are
of
some
simplification.
kind of
So,
simplification.
for example,
So, for
if
example,
this rigid body
if this
is
rigid body
undergoing
is
translation,
undergoing
then
translation, then
its
you know
angular velocity
its angular velocity
must be zero.
must be zero. So
this means if you use
the
mass center point
G
for your calculation
of
angular momentum,
it
must be zero.
It must
Okay?
be zero.
But of course, sometimes you select other
you
points.
select
For
other
example,
points. For
point A,
example, point
for your
A
calculation,
calculation
simple.
could be
It could be
simple.
convenient
It
for
could
you.
be convenient for
And
you.
in that case,
And in that
this
case,
angular momentum
this angular
won't be
momentum
equal to
won't
zero.
be equal to zero.
This is for
This is
translation.
for translation.
Now, for rotation about
have a look. Axis. Have a look.
for linear momentum,
For linear
this is
momentum, this there.
for angular momentum,
For angular
if the
momentum,
calculation
if
is
the calculation
about
is
this mass
about
standpoint
this
G,
mass
then
standpoint
it will be
G, then
IG.
will be IG omega.
If the calculation is
The calculation
about
is
the
about
rotation
the
center
rotation
point O,
center point
then
O.
it will be
Then it will
IO.
be IO.
But this can be
This
worked
can
out.
be worked out from this,
And you will use
and you will use
the so-called parallel axis theory.
parallel axis theory.
Okay, now, if
Okay,
the
now,
rotation
if
center
the rotation
of O
center
coincides
O
with
coincides
this mass standpoint G,
mass
then
standpoint G,
you will
then
have HO is equal to
HO is
HG
equal to
and equal
HG
to
and
IG
equal to
omega.
IG omega.
So that's the equation
That's the
for
equation
rotation about
rotation
x.
about fixed x.
And next,
Next,
it will be general plane
it will
motion.
be general plane motion.
For linear momentum,
For linear momentum,
for angular momentum,
angular
if
momentum,
the calculation is about
the calculation is about
G,
G,
will be IG
will be
omega.
IG
And
omega.
you could select
You
point
could
A
select
for your
point A
calculation.
for your
Okay.
calculation.
Then you will have
Then
two
you will
items.
have two items. Okay.
Now, a specific
Specific
situation.
situation.
If the selected point
If the
A
selected point
is
A,
the IC point
the IC point
of this rigid body
of this
undergoing
rigid
general
body
plane motion,
undergoing general
whatever
motion, whatever
then
happens,
this
then
will be as
it
similar
will be
as
as similar
the
as
equation
the equation
rotation
in
about
rotation
the axis.
about a fixed
And
axis.
you can
And
rearrange
you can
this equation,
rearrange this
and you
equation,
can use
and you can
a
use
parallel
a
axis
parallel
theorem.
axis
So finally,
theorem.
you will
Finally,
about
you
the
will see
IC
about
point,
the IC point,
the angular
the angular
should be
momentum
equal to
should
the
be equal to
MMI
the MMI
of the rigid body
of
about
the rigid body
axis
about
going
the
through
axis
IC
going
point
through the
times
IC point
omega.
times omega.
Okay.
Okay.
Now we have introduced
We have
all the
introduced
equations,
all
and
the
now,
equations.
let's
And now,
have
let's have
look.
a look.
have a look at this
Have a
example
look at this
to
example.
see how we can apply this equation.
Equation.
And this one here is
And this one here is quite
simple
simple example.
And here
And
you can
here
see at
you
this
can see
instant,
at this
and
instant,
there is a
and there
blend
is a
bar.
blend bar.
Its mass is 5 kilos.
Mass is 5
If
kilos.
a blend bar
If a
has
blend
the
bar
motion
has the motion
like this, falling
this,
down, and
falling
we
down,
know it
and
must
we know
be
it
general
must be
plane motion.
general
This
plane
is a
motion.
very simple
This is a
case.
very simple case.
We are familiar with this.
Familiar
we know
with
it's
this,
general plane
and we know it's general plane motion.
Okay, now the task
Okay,
is
now,
to
The
determine
task is to
the angular
determine
momentum
the angular momentum
about the
about
mass
the
center
mass
point G,
center point
and also
G, and
the
also
angular momentum
the angular
about
momentum
the
about the
IC point
IC
of
point
the rigid body
of this
at
rigid
this
body
instant.
at this instant.
Okay, so
So
we will see how
we
to
will see
calculate
how to
angular
calculate
momentum
angular
about
momentum
these 2 points.
about these 2
And
points.
also, we will
And also,
compare
we will
the
compare
magnitude
the
of
magnitude of the
angular momentum
angular
about
momentum
these 2 points,
about
and
these
we
2
will
points,
see
and
the
we
difference.
will see the difference.
So,
So
solve this problem.
solve this
and,
problem, and
we have already
we have already
analysis.
analysis.
Now, let's have a
Now,
look how to solve it.
How to solve it.
Okay, so here you can
So
see
here you can
the
see the rigid body,
the rigid body,
the bar, land bar, AB,
land bar, AB,
and here is the mass center point G.
Mass center point G. Okay.
Okay. Because again, we are going to dealing with vector.
Vector.
For calculation, definitely you will need coordinate system. So in this one here, I define coordinate system X, Y, here. Just for convenience, I define clockwise as the positive rotation direction. If positive rotation direction clockwise, then actually that means coordinate system here. Positive direction of should be inward. Okay, instead of outward. Okay, now we will try to draw the diagram. And in this diagram, we will need to indicate the velocity. To some extent, will be kinematics diagram. Okay, now. Obviously, at point A, the velocity should be downward, vertical, VA. At point B, the velocity should be horizontal, VB. Now, if you know A, know B, their direction, how to determine the location of IC, what we can do is have a line going through point B, and perpendicular to VB. Another line going through point A, perpendicular to VA, and then you will get intersection point here, and this will be the IC point of this rigid body at this instant. And also, if you can work out this IC point, should be very easy to work out from the distance from IC to IC, and let's see the solution. Okay. For this diagram, do you have any questions? Let's have a look. Using. Okay, we have defined problem. We know it's general time motion, and the diagram. To work out angular momentum, we need to understand the mass of the rigid body, 5 kilo, and the length of the land rope is 4 meters. VA is 2 meters per second. And in this problem here, we don't know omega, and we don't know HG and HIC, angular momentum. Okay, the only equation will be like this. And for HG is equal to IG omega. For HIC, you can use general expression, but if you like, you can also use HIC is equal to IC omega for your calculation. Okay. Now, locating the IC.
Locating the IC.
We will use trigonometry.
Trigonometry.
I'm not going to give detailed explanation on this trigonometry calculation process. You have any questions? You can ask me. Anyway, in this one here, this triangle, IC, three sides. So that means angles.
The angle
here, or here, and here. These three angles.
These three angles
60 degrees.
60 degrees.
Then we can work out angular velocity.
Angular velocity.
Land
of
bar.
Land
and the velocity.
And the velocity.
The mass center. Point G.
Center point G. Okay.
For omega.
Clockwise. Should be clockwise.
Okay. According to this
defined
coordinate system.
Coordinate system.
Positive.
Should be.
For VG must be perpendicular to the line connecting IC and G. It should be right angle. So that's why you have that direction of VG. Now, if you can work out then that will be easy. To calculate IG using the established equation
for this land
and then you should be able to easily work out the magnitude of angular momentum of this rigid body about
point G.
Of course, this is vector, so you need to indicate direction. The direction should be the same as the direction of omega. For HIC,
similar.
Okay, again, that's the direction. Now, have a look at the magnitude of angular momentum about point G and the angular momentum about point IC. And you will see about the two different points, the magnitude of the angular momentum rigid body are different. Okay. So this is different from the calculation for kinetic energy of a rigid body. We studied in last week. For the kinetic energy of a rigid body, it doesn't matter what point you select for your calculation. Finally, you will have one magnitude. But for angular momentum, the equation looks the same. For kinetic energy, it will be IG omega squared. The equations same, but they are very much different. Select a different point for your calculation. You will get different magnitude of angular momentum. Okay. So this is the simple example for us to learn how to calculate angular momentum. Any question?